Hello, my name is Alexey Tselykh. I am an associate professor in theoretical computer science and a program director for the master's program in machine learning and big data at Southern Federal University. It was very difficult to choose only one topic for a brief insight into the true magic of data science. Neural networks are possibly the hottest and most hyped technology at the moment. But there is a wide range of other extremely interesting topics to discuss. Among them are the following: the overfitting problem, a fundamental problem in data science; bias variance dilemma; the curse of dimensionality; bagging, boosting, stacking. These ensemble techniques sound like magic spells in Harry Potter, don't they? While random forests resemble a forbidden forest and Hogwarts. Monty Hall problem with a car and two goats behind the doors. Cats versus dogs dataset. The list goes on and on. There is always something fun going on in data science. Finally, I made a choice in favor of association rules. This data mining task was unknown until early 1990s. Since then, it has grown into a gold standard for marketing to boost cross-sales and upsales in supermarkets. Each customer leaves a supermarket with a basket full of necessary and not that necessary goods. The shopping list may vary greatly. A housewife might buy ingredients for a family dinner, while a student might grab a beer and chips. Understanding these buying patterns can help supermarkets to increase sales. If there is a pair or more items that are frequently bought together, the supermarkets can place them on the same shelf for more visibility, combine them into a fixed set or even a new product, offer promotional discounts for just one of the items, or target advertisements in a better way. Association rule mining is a technique to reveal how items are associated to each other. There are three most common ways to measure how interesting and significant is the association. Support shows how popular an item set is, as measured by the proportion of transactions in which an item set appears. In our example, the support of beer is 3 out of 4, or 75%. Item sets can be made of multiple items. For instance, the support of beer and pizza is 2 out of 4, or 50%. You can set a support threshold and then identify item sets with support values above this threshold as significant item sets. Confidence shows how likely item B is purchased when item A is purchased, expressed as A entails B. This is measured by the proportion of transactions with item A in which item B also appears. Confidence is calculated as support of the item set divided by the support of the antecedent. In our example, the confidence of the rule beer entails pizza is 2 out of 3, or 67%. One drawback of the confidence measure is that it might misrepresent the importance of an association. If beer is very popular in general, there will be a higher chance that a transaction containing pizza will also contain beer, thus inflating the confidence measure. Lift shows how likely item B is purchased when item A is purchased, while controlling for how popular item B is. A lift value greater than 1 means that item B is likely to be bought if item A is bought, while a value less than 1 means that item B is unlikely to be bought if item A is bought. Lift is calculated as support of the item set divided by the product of supports for antecedent and consequent. In our example, the lift of the rule pizza entails beer is 0.89, which implies no association between items. It sounds pretty easy to calculate the popularity of a single item set, but supermarket owners are interested in having a complete list of popular item sets. To get this list, one needs to calculate the support values for every possible configuration of items, and then shortlist the item sets that meet the minimum support threshold. The a priori principle can reduce the number of item sets we need to examine. The a priori principle is: if an item set is infrequent, then all of its supersets are infrequent. This means that if milk was found to be infrequent, we can expect beer and milk to be equally or even more infrequent. So, further on, we need not consider beer and milk nor any other item set configuration that contains milk. At the next step, we make up all possible rules and calculate confidence or lift for them. The pursued goal is to find new, non-trivial association rules that can be explained and take advantage of this. Association rules can also be used in other fields. In team sports, they reveal which players interact better. In medicine, they help to understand which symptoms or diseases tend to accompany each other. Today, we talked about association rules mining. It was a very brief introduction into data science. I hope you enjoyed it. I look forward to seeing you among the students of Southern Federal University, be it a summer or winter school or our master's program in machine learning and big data. I wish you all the best.